Session is getting recorded here. Yeah, now it's getting recorded.
Okay, fine.
All right. Hello, everyone.
Muted.
Welcome to today's webinar, which is all about clustering analytics. This is the second webinar of the series of clustering webinars that we are having. In the previous webinar, we have discussed about theoretical aspects of the various K-means clustering family that we have, such as K-medians, K-medioids, partitioning around medioids, clustering large applications, Clara, K-modes clustering, so on and so forth. We have discussed about a bunch of different clustering techniques that exist. Today, we are going to discuss about a different family of clustering, which is called as density-based clustering. Within density-based clustering, we have primarily two algorithms. One is a density-based clustering algorithm, and another algorithm abbreviation is optics. And as part of next series, we will be discussing about optics. But for this webinar, we will be discussing about DBScan, which is called as density-based clustering algorithm. Let us understand theoretical aspects of this algorithm, and then we will practically look into a specific data set and perform this particular algorithm using R programming. So density-based spatial clustering of applications, that is what DBScan stands for, with noise, of course. So if I were to highlight, D stands for density, B stands for based, S stands for spatial, C for clustering, of A stands for applications, and N stands for noise. DBScan primarily has two parameters which we need to understand. Parameter 1 is called as EPS, maximum radius of the neighborhood. We'll discuss about these. And another parameter is minimum points. That is minimum number of points in the EPS. Yeah. Now let us try to understand. EPS, say, is 1 unit. One is, assume the radius. So if this is the center point, then if 1 centimeter or 1 millimeter or whatever unit you have, if that is your EPS, then you simply draw a circle. You simply draw a circle of 1 unit radius. So radius of this circle is 1 unit. How do you determine EPS? What should be the value of EPS? We will get to that. However, just try to understand theoretically what EPS means. If EPS is 2, then the radius will be slightly large, and then you draw a circle by considering that radius. What do you mean by minimum points? Okay. Minimum points is nothing but how many minimum number of points do you intend to see within that EPS neighborhood. That means, say this is the center and I have 1 unit radius, and then I draw a circle. Within this circle, how many points, minimum number of points, do I intend to see? Say I want to see 5 points, minimum 5 points. So what does that mean? What do you want to explain using these two parameters, EPS and minimum points? So here we need to classify all the available data points, or think about all these data points as records in a data set, all the rows of a data set, right? And then you're trying to cluster those rows. when you try to cluster those rows, you can put that in two-dimensional space and view it. Any point is called as a core point if it has more than a specified number of points within EPS. So for example, if this is the center and if the EPS is 1 unit, with 1 unit you draw a circle. Within that circle, do you have at least 5 points because you set minimum points as 5? So do you have 5 points? Yes, 1, 2, 3, 4, 5. So this point is called as a core point. Okay, a point is a core point if it has more than a specified number of points within that circle or within that EPS. Okay, so EPS, minimum points, think about these as, say, K-means clustering. Within K-means clustering, what is K? Right, the number of clusters. So that's a parameter that we are discussing about, right? Like your linear regression has beta naught, beta 1 and all that. In that way, we have some parameter called as EPS, and I've already explained about EPS. On what is EPS? The maximum radius of the neighborhood. Okay, radius, you know, circle, radius. That's EPS here. It's given that name and it is given this notation. All right. Now, what is a border point? Code point should be clear now. That point which has more than specified number of minimum points within that circle, within EPS radius, is core point. Now, what is a border point? A border point has fewer number of minimum points than the specified minimum points. So if the specified points is 5, you will have less than 5. However, this will be in the neighborhood of the core point. Here is a core point. It's in the neighborhood, immediate neighbor. It can be on this side, on that side, on any side basically. But if you look at this point, border point, does it have minimum 5 points within this EPS? No, it doesn't have 5, right? How many does it have? Only 1. So that is called as a border point. Now, what is a noise point then? Noise point is that point which is neither a core point nor a border point, something which is extremely different. It doesn't have any core point as a neighbor, neither is it a border point. Okay, that's called as a noise point basically. So these are the 3 points that one should be aware of. Why do we need to know about these? Core point, border point, and noise point? Because we need to do clustering. Any 2 core points are close enough within a distance EPS of each other are put in the same cluster. So any 2 points or any 2 core points rather, which are close enough within a distance EPS of each other. That means if you say EPS is 1, 2 points should be within that distance. Then you put them into the same cluster. For example, if you think about this another data point, right? This another data point. If you draw an EPS like that, a circle, then maybe it will have 5 data points within the circle. If yes, then these 2 will be part of one cluster. Okay, think about maybe some other data point. If you draw an EPS, right? If this core point and this core point, if both of these are within the distance of EPS, then these 2 are clustered together. Okay, So all those core points, what is a core point? Minimum 5 points in this scenario should be there within this EPS. That's the definition of core. Any two core points, if they are within a distance EPS of each other, if they are within distance of 1 centimeter to each other, then they are put in the same cluster. And any border point that is close enough to the core point is put in the same cluster as a core point. So assume that this is one core point and this is another core point, and this is a border point. So this will be part of this cluster. Okay. Now, noise points are discarded. You do not cluster it with anything. In order to visually understand this, let us look at this. Optics is something that we're going to discuss as part of next clustering series, which stands for ordering points to identify clustering structure. But for now, we'll focus only on DBScan. If this particular data set is provided to you, when you plot, if it appears like this, then how many clusters do you think exist? Yeah, look at this and tell me on how many clusters do you think exist? I request you all to please put that on the chat window. If you say you plotted the data and you appeared and you are seeing this kind of a representation, then how many clusters do you see? Or how many clusters do you expect? Yes, I see a lot of you all responding. I request everyone to please respond. All right. What could those clusters be? What could those clusters be? Probably this linear representation of data would be one cluster. This linear representation of cluster of data points would be another cluster. This would probably be a third cluster. This inner oval shape, this shape would be one cluster. And then this outer oval shape would be another cluster. So that means you have one cluster, you have the second cluster, you have the third cluster, and then you have fourth cluster, and then you have a fifth cluster. So you have 5 clusters, right? However, if you tend to use your traditional algorithm, clustering algorithm techniques, such as K-means clustering, then K-means clustering would create these clusters basically. It would consider this as one cluster, this as a second cluster, this as the third cluster, all these as a fourth cluster, and this as a fifth cluster, which is obviously wrong in comparison to what we have just discussed. We have discussed that this could be one cluster, which is right. This could be another cluster, which is absolutely right. This should be third cluster. Once again, that's right. This will be the fourth cluster, inner oval, right, and fifth cluster. However, here K-means clustering is taking a different direction altogether. So your traditional algorithms might not always work. Given your data, when you do your exploratory data analysis properly, you would be able to identify on which clustering technique works well. Okay, so clearly K-means clustering would have given a distorted set of clusters, and if you strategize, if you devise some strategies on each of these clusters which are formed based on K-means clustering, you would have certainly gone wrong. Okay, so I'll show that practically once again on R. However, look at this, a quick recap kind of. We need to provide 2 parameters, EPS and minimum points for this algorithm. EPS can be mathematically calculated. I'll show you the plot. But minimum points, it can be arbitrarily taken. You can do your experimentation with various minimum points. And density of a point is defined as the number of points within a specified radius. That's EPS. That's called as density, how dense the data is. Okay, clustering and classification are two different things. Clustering is used to create groups of related things. Classification is a machine learning algorithm, right? Wherein you classify on whether a specific credit card transaction is fraudulent or not. You classify on whether a person will pay your loan ahead of time, on time, or with a delay, or will willfully default. Classification. Clustering is grouping the related customers together. All right. Now, this DBScan algorithm divides the points into three groups based on density, which we have discussed: core points, border points, and noise points. All right. Now, before showing that, let me go to R. In order to run DBScan algorithm, there is a package called as DBScan. You just need to install that package. And once you install, you know for a fact that you also have to invoke the package. Then, whatever data set we want to cluster has to be chosen. So read.csv file.choose will actually pop up a specific window, all right, using which you can select the data set which you wish to. That is DBScan. And using this assignment operator, we are assigning it to an object called DF. This particular data set has 1,100 observations and two variables. Why only two variables or two features? Just because I want to show you on how clustering happens. Now, if I plot this particular data set, this is how it appears. And this is exactly what we have seen as part of the screenshot. 1, 2, 3, 4, and 5 clusters are there in this. Let us do K-means clustering on this data set. I want 5 clusters because by looking at this visualization, I sense that there could be 5 clusters. So I want to run 5 clusters. And number of starts equal to 25. So people who are aware of K-means clustering know for a fact that when you want to run 5 clusters, K-means clustering initially would select randomly 5 data points as 5 cluster centers, and it starts running this particular algorithm. And these data points are randomly assigned once. Okay, and ultimately whatever cluster is formed, you take those as the final clusters. However, K-means clustering is sensitive to initialization. Initialization, how you initialize, how these random points are selected. Based on that, the kind of clusters formed vary. So here, in order to avoid having 5 random data points selected such that it doesn't form a good cluster, in order to avoid that situation, we are running this algorithm say 25 times. So randomly 5 data points are selected, one cluster is formed. I want again another set of 5 data points to be selected. Again, I want another set of 5 initial data points to be selected, and then I want K-means clustering to be run again. So if I do question mark of K-means, you see here number of starts. By default, it is only 1. Okay. If centers is a number, how many random sets should be chosen? Okay, that is what number of starts mean. Okay, now I'll run this Kmeans clustering. Done. The result of Kmeans clustering is stored in km.res. I want now to plot this particular data set, and I want to color it based on K-means clustering clusters. So if you run this, only this part, km.res stores the K-means clustering. If I do $cluster, it shows which data point belongs to which cluster. You have 1100 observations, right? First data point or first observation belongs to cluster 4. Second observation out of these 1100 belongs to cluster 1. In that way, you have the data, right? So I want to plot this original data set. That is nothing but this part. It's already plotted. And then I want to color these data points based on the cluster number. So all cluster 4 data points would be given one color. All these ones will be given one color. All the 3s will be given one color, so on and so forth. Why am I using +1? I'm just adding 1. So if it is 4, 4 plus 1 will become 5. If it is 1, 1 plus 1 will become 2. If it is 3, 3 plus 1 will become 4. I'm doing this just because, so let me run this. Just because the coloring aspect is a little weird here. If I do +1, it will be slightly better. That's the only intention, nothing else. Okay, look at this. This is exactly what I've shown you. How many clusters do you see? Good, you see right number of clusters, if I'm not mistaken. So this is one cluster. This is another. This is the third one, fourth, and fifth. But we know for a fact that this is wrong. So K-means clustering is giving you wrong results. So how do you fix it? You can fix it using DBScan algorithm. All right, even before that, I've told you that within DBScan, you need to provide 2 parameters. One is EPS, which is nothing but similar to radius, and another is minimum points. Minimum points, how do you decide? It's by looking at this plot. I know for a fact that there could be 5 clusters, so I decided minimum points, right? Sometimes you might not be able to identify minimum points in such a easy way, so you'll have to do some kind of experiments there, but EPS certainly can be found. Now, in order to find EPS, let me run this. KNN is K nearest neighbor. It is K nearest neighbor. Okay. People who have attended data science training from XLR Solutions must be aware of this algorithm by now. Do we have anyone who is attending this session who does not know what is K nearest neighbor? Anyone? Or is it safe to conclude that everyone understands K-means clustering? Sorry, K nearest neighbors. Okay, all right. I think everyone understands what is K nearest neighbor machine learning algorithm. Say you have multiple data points like this, and you have a new data point, assume. If you do 1 NN, if I say K equal to 1 NN, then you find the distance between this data point, new data point, to all the data points, and you choose the least distance. Okay, and say you have a 2-class problem. You have this black class, and you also have blue classes like that, data points. Okay. If you do 1NN, then you know for a fact that the least distance of this new data point will be to the blue class. So you'll assign this a blue class. If you do 2NN or 3NN rather, you'll try to find the 3 nearest data points, and maybe these are those 3 nearest data points. Out of these nearest data points, 2 of these points are blue color. So this new data point will be assigned a blue class. So that's the underlying logic of Kmeans. The same concept is applied here also, wherein you are saying I want to run a 5NN algorithm and want to do a distance plot. Okay, on this data set we are running k equal to 5. I ran that. Look at this. This is like your scree plot only, but this is called as EPS plot basically. Now, or I think this is also called as a knee point or something on those lines. Okay, or ankle curve, something like that. Okay, anyways, so look at this. Wherever there's a steep bend, you have to stop there and you have to look at what is the corresponding EPS value. What could the corresponding EPS value be? So let me minimize this a little to explain you on why we have chosen this EPS as 0.15. So here you see that bend, it might be somewhere here. Ideally, you look at the bend and then look at what is the corresponding EPS value. So EPS value here happens to be 0.15. Of course, this will be 0.15 here. So that is how you determine on what would be the EPS value. So I know what is my EPS value. I know what are the minimum points that I'm looking for. Minimum points is number of clusters, kind of, right? And then if you run this algorithm and then save it on DB, job done. Now if I plot this, you'd be able to see the results. So I'm plotting this DBScan algorithm. And once I plot it, I will do DB dollar cluster. So let me do DB dollar cluster. This will show you information about which data point belongs to which cluster. Okay. And I'm adding 1 to it because you also have zeros. Right. I think 0, 1, 2, 3, 4 in that way it is classified. 0, it doesn't get, it will not get plotted basically. Okay. 0 will not get plotted. Hence, I'll say +1. This is another reason why you add +1. Okay. In this scenario, it was just to get some beautiful color. All right. But in this scenario, we are adding 1 because if you have 0, it doesn't show you any color basically. Okay. I can remove this and plot and show you. Okay. So that's how it is. Now, let me add a +1 and run it. All right. Now, do you see those outliers? All these blacks are the noise things which are left out basically. For the rest, yes, you see those clusters. So this is one cluster, this green. This is another cluster, the red one. Blue is another, light blue is another color. Pink is another cluster. This is simply put DBScan algorithm, which works very well. Okay, when you have data which is like this kind of representation. Okay, always your K-means clustering or hierarchical might not work well. Okay, and that's what it is. So if you have zeros, it doesn't plot is what I told. Yes, it wasn't plotting the outliers there, but now you also see the outliers. Main is a main title. If you put sub, it will become a subtitle. Yes. All right. So Karthik, you can stop the recording now.